5.4 moves beyond Pythagoras' theorem to another feature of right-angled triangles. So Pythagoras' theorem works in right-angled triangles, so does trigonometry. To be able to get a handle around trigonometry and explain that, the first thing we need to do is we need to be able to label the other two sides of a right-angled triangle. So we already know the hypotenuse, that's the longest side, and it's always straight across from the right angle. The other two sides for trigonometry also have a name called opposite and adjacent. Those two words come from the angle that we're talking about. So we have one that is opposite the angle, which is straight across from the angle that we have labelled here in red called theta. And we have one next to or adjacent to the angle. There's two sides adjacent to it. One's always the hypotenuse, the other one we call the adjacent. So that opposite and adjacent name will change if we change the angle that we're interested in. So although the hypotenuse will always stay the same in a right angled triangle, the opposite and the adjacent depend on which angle, which corner that we're talking about in the triangle. So the bottom right angle, there's the opposite and adjacent, and when we have the angle in the top left, then you can see that the opposite and adjacent swap positions. Hypotenuse stays the same. So we're going to use these names to describe trigonometric ratios. A trigonometric ratio compares one of these sides with another one. They're called sine, cosine and tangent, or sine, cos and tan for short. So what are they? What do they mean? Where do they come from? If you have a look at this triangle here, it's a right angled triangle. In fact, there are three of them stacked in the same space. We've got a red one, we've got a green one and a black one. All three of these triangles have got one feature that is identical, and that is the angle down in the corner is 30 degrees for all of them. If you compare the opposite side to the hypotenuse, you might notice something. In the red triangle, the opposite side is exactly half as long as the hypotenuse. And in the green one, the same thing is true, 8 and 16. And in the black one, you get the same thing again. It's a feature of every triangle that has a 30-degree angle in the corner that the opposite side to the angle, when you compare that with the hypotenuse, it's exactly half as long. When we compare the length of the opposite side with the length of the hypotenuse, what we're doing is what we call finding sine of the angle. If we compare the adjacent length with the length of the hypotenuse, we call it cosine. And when we compare the opposite and adjacent, we call it tangent. So the three ratios are sine, cos and tan. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We call them sine, cos and tan for short. The way that we can remember that is with the ancient Japanese word of sakatawa. So sakatawa helps you remember it. Can you see how? Sine, opposite hypotenuse, cos, adjacent hypotenuse, tan, opposite adjacent. So the letters that make up sakatawa help you remember the three ratios of sine, cos and tan. So we've seen how sine of 30 degrees always comes out to equal a half. So it tells you that the opposite side is half as big as the hypotenuse. We can make use of that in finding out values, but not just in 30 degrees, we can use it for any angle. But let's just stick with 30 degrees for a little while and see how we can use it to find the length of a missing side. Okay, let's have a look at how we can use the three trig ratios to find missing sides. So here's a fairly poorly drawn triangle because that doesn't look anything like 30 degrees, it looks more like 45 or 50. But we can see we've got an opposite side and we've got a hypotenuse there, 30 degree there, Some of you might already know what the answer is going to be because we've already seen what sine of 30 degrees is. Did you guess 5? Let's have a look at how you'd set it out normally. And if the angle wasn't 30, you're going to need this technique. So the first thing we need to do is to identify the names of the sides that are involved. In a trig ratio, there's always 2 sides and an angle. So this one has got the opposite side, and it's got the hypotenuse, and it's got the angle. There should always be 2 values that we know the length of, in other words the angle and the hypotenuse in this case, and one side that we don't know the value of, that's the side that we're looking for. In this case we're calling it x. So once we've identified the names of those sides, we can then start to have a look at which of the 3 ratios we need to use to solve it. So opposite and hypotenuse, if you use SOHCAHTOA, we can identify that that is sine. Sine, opposite, hypotenuse. I always start by writing out that ratio, sine theta equals opposite over hypotenuse. And then I need to fill in the 2 known values, the 30 and the 10, and I need to fill in also the name of the unknown value, the x. From here, it's a matter of doing a bit of algebra and using your CAS to finish that off. Now, there's a couple of things you've got to be aware of with your CAS for this to come out with the right answer. So there's actually a few different ways that you can measure angles. And one of the ways that you can do it is with this thing called degrees that you've used. There's 360 degrees in a circle, we all know that. But there are also angle measurements called gradians and radians. So you need to be careful that your calculator is in the right angle measurement. Through VCE you'll mainly use radians, but this year we're still using degrees. So if you go to your home page by pressing that home symbol button, then you can find that there's document settings, and then you can set it into degree mode. If you've got your calculator correctly set in degree mode, then you're going to find up the very top right hand corner next to the battery symbol, it'll say DEG. If it says RED, it means you're in radian mode. To be able to use sine, cos or tan, you can type SIN using the keypad, or you can press the trig button and then a little menu will pop up and you can select sine or cos or tan. You can also select a few other things which we'll talk about later. Down the bottom left of your keypad you'll find a pi button, and if you press that pi button you can get pi, but there's also underneath the pi a degree symbol, a little circle there, and if you type that in you can force your calculator to figure out sine of 30 degrees even if it was in radian mode. So up the top there next to the battery I've got the DEG, so I didn't really need to do that, but even if it said RAD, as long as I put that degree symbol in, it would still find sine of 30 degrees and not 30 radians. So let's have a look at what the final problem is going to look like. The first thing I always do is I try and draw my diagram with the angle roughly correct. So that 30 degree angle, if I draw that roughly correctly, I can easily see that the opposite side is about half as big as the hypotenuse. Makes it really easy to pick up mistakes in your answers if you just take that little few seconds to try and get that angle right. I'm careful with my labelling in the diagram, of course, as usual. The next step that I need to do is I need to write down the trig ratio involved, sine theta equals opposite over hypotenuse. Then I make my substitution of my 2 known and 1 unknown, and it usually involves 2 to 3 lines of working with some buttons pressed on your CAS calculator to get to your final answer. The only other thing to watch out for is to make sure that you have included any units in the final answer. So that's what I'd like to see for every problem that you do: a diagram, the trig ratio written, the substitution, and then a couple of lines of working for your final answer. Please don't skip out on that. It's really important that you do that every time.